everyone, today we are going to discuss about the transistors. So first of all, what is transistor? Transistor is a 3-port device and having a region like emitter, base, collector, and it is also a current carrying device. Transistors are basically used in amplifiers. So what are amplifiers? Amplifiers are basically a component which is we are going to use to boost the circuit or to boost the waveform by keeping the waveform in a same position. Now transistors are also active components. So what are active components? Active components are basically the current suppliers of the circuit. So in transistors there are two type of transistors. First is unipolar or field effect transistor, second is bipolar junction transistor. What are the difference between a unipolar and a bipolar junction? In a bipolar junction transistor, the operation of a BJT is totally depend upon the majority charge carriers as well as the minority charge carriers. Majority charge carriers may be holes or electrons, and minority charge carriers are maybe same, the holes or electrons. But in unipolar or field effect transistor, the operation is only depend upon the flow of majority carriers, either of holes or electrons. So in a bipolar junction transistor, one of the important use is amplifiers, and they are also made up of a semiconductor devices, and generally transistors are highly efficient and usually inexpensive. So in these kind of things we are basically use transistors. So in what are the construction of BJT? BJT are made up of two PN junctions like PNP and NPN. When the P is sandwiched between the two N terminals, it is known as NPN, and when N terminal is sandwiched between the two P terminals, it is known as PNP. So there are the two possible arrangements. First is PNP and second is NPN, and the three regions of terminals and the three regions of transistor, which are known as emitter region, base region and collector region. So we can give the input through emitter base and collect the output through collector region. So this is the construction of BJT. You can see that when N region is sandwiched between the two P regions, this is known as PNP transistor, and when P region is sandwiched between the two N region, it is known as NPN transistor. So you can correctly check what is PNP transistor and what is NPN transistor. So what is the construction of BJT? It is basically it is a 3-terminal device and it is made up of semiconductor. Now what is the material, the semiconductor material? It is basically depend, either it can be behave like an insulator or a conductor. In an earlier presentation we can talk about the semiconductors. So what are the semiconductors? Semiconductors are when the conductivity lies between the conductor and the insulator, then it is known as semiconductor. So semiconductor sometimes behaves as an insulator and sometimes behaves as a conductor, and this is totally depend upon the application of a small signal voltage. And what is a small signal voltage? Small signal voltage is the ratio of input signal to that of the output signal. So the transistor's ability to change between these two states enables us to have two basic functions. First is switching, second is amplification. What is switching? Switching is basically of digital electronics. What is digital electronics? In this digital electronics, the input of the wave and the output is totally depend upon the digits, that is 0 and 1, and amplification is totally depend upon the analog electronics. Analog electronics is totally depend upon the waves like sine wave, cos wave. So these are the two functions, switching and amplifications are the functions which are going to perform by the transistor, and it is of 3 regions. Transistor behaves or operate in 3 regions. First is active region, second is saturation, and third is cutoff. You can look at this. In the active region, the transistor operates as an amplifier, and the collector current IC indicates the collector current and IB indicates the base current. That means IC current is equal to beta IB. Beta is the beta is the constant. Sorry, beta is the constant. Now second is saturation. Saturation is that operation where transistor is fully on or fully in operating mode, that means the collector current is equal to the I, means the saturation current, and the cutoff, the transistor is fully off, that means the collector current is equal to 0. These are the three conditions in which the transistor is going to be work. Now what are the configurations? Bipolar. Now what is bipolar transistor configuration? In a bipolar junction transistor, there are three type of configuration. That is, first is common emitter configuration, second is common base configuration, third is common collector configuration. So now what is common? What is the meaning of that word common? Like there are three terminal devices. First terminal is emitter, second is base, third is collector. So for the input purpose we need two terminals, and for output purpose we also need two terminals. So for input purpose we need two terminals, that means we use emitter and base, and for output terminal we use emitter and collector. So emitter is common in input as well as emitter is common in output. So this is called common emitter configuration. Common emitter configuration is the widely used configuration in the transistor, and this configuration is used in amplification process. So there are three configurations like common emitter. In this common emitter configuration, emitter is common in input as well as in output. Now common base is common in input as well as in output, and now common collector is common in input as well as in output. Like now next is, you can see that bipolar transistor configuration, first is common base, has voltage gain but no current gain. Common emitter configuration has both current and voltage gain, and common collector configuration has current gain but no voltage gain. That is why common emitter configuration is widely used, and it is also used in amplification process because it has both current as well as voltage gain. Now you can see the bipolar transistor operation. This arrow is basically indicates the flow of the conventional current. You can see that the arrow on the emitter indicates the direction of conventional current flow under bias condition. You can see that in this, the arrow coming outwards, and in this PNP arrow coming inwards. In NPN, P is sandwiched between the two terminals of N, and in PNP, N is sandwiched between the two P terminals. So in now, what is the operation? The majority of current in PNP transistor is carried by the holes. Okay, so being positively charged, the direction of a conventional current or the direction of the positive charge particles are the same. So in NPN transistor, the majority charge carriers are electrons. So what are the majority charge carriers in PNP is holes, and what in the majority charge carriers in PNP is holes, and the NPN is electrons, but both the operation of PNP and NPN are the same. So we can study only one, you can automatically get this next one. So this is PNP, emitter current going to the P junction and collector current is coming from the P junction. This base junction, we can use emitter, collector, base, VBE and VC. You can see that the collector current is basically equal to IE, that is collector current minus IV. So in the next amplifier, the PN junction, that means the junction between collector and base is reverse bias. That means if we take a common emitter configuration, let's take an example. If we take a common emitter configuration, that means in a common emitter configuration, the emitter and base, like emitter is common in input as well as emitter is common in output. So emitter base, the junction between the emitter base is forward bias, and the junction between the collector and base is reverse bias. So in a normal use as an amplifier, the PN junction between collector and base is reverse bias, and the junction between emitter and base is forward bias. And now the next is bipolar transistor operation. Basically the operation of a transistor is totally depend upon the width of the material or the construction of the base region. If the width of the if the base region is decreasing the size, means that if we reduce the size of the base region, the collector current automatically gets increases, while reducing the base current, you can say that while reducing the base current, the collector current automatically get increases. And the emitter current is basically depend upon the base emitter voltage, that is VBE. you can see the common emitter configuration in a circuit form, like this is a signal and this is the base, this is collector, this is emitter. Emitter is common in input as well as emitter is common in output. This is VBB, that means voltage at the base junction, and VCC, that is voltage at the collector junction. So in a common emitter configuration, we can say that the input impedance is low as it is connected to a forward bias PN junction, while the output impedance is high as it is connected through the reverse bias junction. This configuration is commonly used in all the transistors, and this is the configuration which we are going to use in amplifiers, which represents the normal method of bipolar transistor connection. So the next is, in this configuration, the current IE current means the current at the emitter is equal to the current at the collector plus current at the base. This is going to be added. Collector current and base current is going to be added equals to the emitter current. The current flowing, that means the current flowing out of the transistor must be equal to the current flowing into the transistor in a emitter current, in a common emitter configuration. So the current gain of the emitter transistor configuration is quite large, as it is the ratio of IC upon IB is given by beta symbol. That means the ratio of IC upon IE is equals to alpha signal. That means IC upon IB is equals to beta, and IC upon IE is equals to alpha, and IE is equals to IC plus IB. So the electrical representation of these circuits, you can see that IB, IC and IE is determined by the physical construction of the transistor. And now the common, then we can summarize that this type of BJT configuration has a greater input impedance, current and power gain than that of the common base configuration, but its voltage gain is much lower. The common emitter configuration is also inverting amplifier circuit, resulting in the output signal being 180° out of phase with the input voltage signal. Now these are the some advantages of transistor. You can see that it is a smaller mechanical sensitivity, extremely long life, no power consumption, fast switching, and it is because of this smaller size we can use in many circuits. And this transistor is basically used in amplification of the circuits, because to boost the power of the circuit by keeping the waveform same. Now these are the some disadvantages. Transistor has no zero on resistance, hence when it is on, voltage across transistor is never zero. So manufacturing techniques are very complex and requires clean room environment. And these are the applications. This like BJT can cause a greater current flow from the emitter to collector when a small amount of current is passed through the base. And the core of transistor includes switching applications, or both has amplification and switching. So basically we in the past slide we can talk about switching and amplification. Switching is depends upon the digital electronics, where the input and output works on digits like ones and zeros, and this amplification is based on analog communication, analog electronics, and in this the input and output depends upon the waveforms, that is like sine wave and cos wave. And we can now we can summarize this. In this transistor we studied about the introduction of a transistor, the manufacturing of the transistor, construction, operations and everything. Now in the next topic we are going to study about the rectifiers. Thank you.